So they want a probability that no more than 4. Okay, so probability no more means cannot be greater, but less than or equal to 4. And we always use letter X. So when we do this approximation by the normal distribution, we have binomial, so only the whole values are possible. So when they're talking about 4 absent students, we cannot have 3.5 students absent or 3.6. So it's either 3 or 4. But when we start to do the approximation, we need to make sure it's a continuous distribution because our binomial is so-called discrete. So we use the normal, that which is continuous, so any value is possible. So I just need to select when X is not just equal, but also smaller, which means it could be 3, could be 2, could be 1, so less than or equal to 4. And then border line in between of highlighted region and not highlighted region should be at 0.5 increment, which is going to be right in between 4 and 5, which is 4.5. So my continuity correction is going to look like X is less than or equal to 4.5. And this has a lot of use in practice. So let me pick a problem that may be good to see how we using this in the real life situation. So I'm just looking at the exercises. Let's say 21. That could be a problem that some people sometimes encounter at the airports when a flight is overbooked. And they say that the companies have tendency to sell 400 tickets for the flight with only 350 seats. How would you like that? That's definitely not very fair, right? So they want to know the probability that when they book 400 people, not enough seats will be available. So what's the probability that number of people that came to the airport is more than they have seats, and looks like they have 350 seats. So when not enough available, then it's greater than 350 number of passengers that actually came to the airport. So they sold 400 tickets for that airplane, and what's the chances that more than 350 will show up if a probability that person actually comes to the airport is p.85, which is 85%. So notice that we don't have mean, we don't have standard deviation. So we have to use those two formulas, NP instead of mean, and instead of standard deviation will be a square root from NPQ. And because you're using these formulas, you're doing continuity correction on that 350. So we need to get the favorite setting here and try to picture that X is greater than 350, right? So that's why I put 350 in the middle, then it'd be 351 passengers or 349 passengers. So let us see how we can picture this inequality. And looks like greater than 350 means 351, 352, and so forth all the way to the right. And here's the border, and the number 350.5 is what we have to use for our continuity correction. Again, we do this because we don't have mean and we don't have a standard deviation given to us, so it's not normal distribution, and we produce normal distribution by doing this 0.5 increment. Also, I need to recall that Q, which is a friend of P, its complement, right, is a 1 minus P, or 1 minus 0.85 is going to be utilized, and that's a 0.15. So this is my P and Q. So when I start to calculate z-score, because my goal now is to utilize the standard normal distribution, right? And I have to know what z-score to use that will correspond to this value of x that we're dealing with. So for z-scores, we have formula x minus mean over standard deviation. That's the formula for z-score that we're using here, since we need to convert this binomial distribution to the normal. And value of x, we given us 350.5. Instead of mean and standard deviation, I'll just put n times p, which is 400 multiplied by 0.85. This is our n times p. I let calculator take care of this on its own, because I don't want to do the intermediate calculations. I'll just put everything at once in my calculator, and it will give me a nice answer. So same with a Q. So Q is a square root from, actually standard deviation is a square root from NPQ. So I'm going to be using a calculator here so we can get our answer. So it looks like I can enter all that in a calculator and get the result out. So let me do this. I get this 350.5 minus 400 times 0.85, right, in the parentheses, and then divide by square root from 400, which is multiplied by 0.85 and also multiplied by 0.15. So we got this z-square of 1 and a little assumption, 1.470, etc. So 147. That's what we always use, because tables only care for place of hundreds, right? So go for the positive part of the tables, which is lower than negatives, and get, looks like it's a standard procedure that we numerously encountered already in the exercises. So I need 1.4 for the row and 7 for the column, right? 0.7, so it's 0.9292. Okay, that's not the answer as of yet, but we're almost there, because now I have to see what on the opposite side is. And since this is a distribution, the whole area is 1, and that's why to get the answer I subtract from 1 and I get whatever we have, 0.708. 7% chance that the flight will be overbooked. Well, that's definitely concerning, because there is a chance. If it was like 1%, you'd say, yeah, that's not going to happen. But 7%, it's like 7 flights out of every 100 of them are actually being overbooked. And that's too much, right? That's very, there is a chance that you're not going to make it to the flight, even if you're on time, because somebody else already sits on your seat, and that's definitely no good. So looks like that's a possibility, right? So no wonder why some people running when they're at the airport, and just want to make sure they're first and take their seat, because otherwise, who knows what can happen. So I guess best idea is not to fly, right? So that'd be safest way. But anyways, we see that this is definitely a real life situation that you can calculate. So now what I want to do is skip chapter 6 for now, because I'm really concerned with chapter number 7, and then we will return to chapter 6. Turns out these two chapters are not related. You can talk about them in any order. And I think that chapter 7 is very, very useful for real life applications. And that's the reason why I think I should talk about chapter 7 first, so we spend enough time on it. And then whatever time remains, we'll look at sections of chapter 6. So chapter 6 is talking about various hypotheses that people can make. Where's that page? And oh, here it is. And they may be various claims, and those claims may be correct or may be incorrect. You may agree with some claims, may disagree. Turns out it doesn't matter here. Here we'll be testing those claims statistically. And that's the power of the process. You can claim whatever. And statistically, we can either say, yes, this is correct claim, or no, this is not correct claim. Of course, we need to have some sample and see what is going on. So you can check just about anything, because pretty much anything goes under the normal distribution. So here they give some examples of possibilities. I'd like to look at the cases with mean, because that's what we spend most time on. And then we'll look at the others. So with means, the possible cases could be that mean is greater than 0. Let's say, well, here is 98 points. Well, it could put any number. I think it doesn't really matter, but 0 looks kind of better to me than some decimal. May not be very intuitive, but it's either greater than 0, or it could be smaller than 0, or it could be equal to 0, right? So those are 3 possibilities that you have to compare with a 0, that mean. And now we're going to produce so-called hypothesis. There's a H index 0 and H index 1. Turns out the rule says that if you have equal sign, it must be H index 0. If you don't have equal sign, it must be H index 1. Let me write it a little bit better, because I think I put it in such a way there's not enough room to stick my H. So I guess I'll just move this a little bit to the right. So greater could be smaller, or could be equal. So these are the three possibilities. So when we have a equal sign, that it must be H0. And if we don't have equal sign, well, it must be H1. So here and here is H1. And of course, those are three separate cases. So I need to also put H0 hypothesis, which is going to be always alternative to what we have in H1. So H1, H0 are the opposites. So if H1 says mean is greater, then the opposite will be less than or equal. So equal isn't the opposite, and equal falls into H0, and that's just what I need. Same for the other example. So mean must be greater than or equal, which is opposite to smaller, and that's H index 0. Or finally, for the third case, if it's equal, the opposite will be not equal. And turns out that not equal means that it's either less than or greater. So mean could be either on the left side from 0, or mean could be on the greater side from 0. I'm muted. Can anybody hear what I say? I don't think I'm muted. Maybe your computer is muted. You can hear. I see. Yeah, sometimes computers have the mute on the volume, and you should always, first of all, that's what I do. If I don't hear something, I check the volume on my computer, because if I turn off the volume on my computer, definitely I'm not going to hear anything at all, right? So check the volume on your computer first. And sometimes if it doesn't work, sometimes you can just turn the computer off and then on. I guess that's pretty much the only solution I can recommend, because otherwise might be something wrong with the computer if that doesn't work. But looks like it's working. So anyways, picture for each of these will be related to H index 1. So we always make a picture to the so-called alternative hypothesis. And the picture of H1 will be here on the right side for the first case, because it's greater than 0, somewhere on the right. For the second case, it's going to be on the left side, because now we have this H1 on the left side from 0. So that's going to be the region someplace here. And finally, on the last one, we have both and less than 0. So and the left side and the right side. So our H1 will be composed from two equal pieces. They're equal because picture is symmetric. So this way we start all of the exercises in the chapter. So we produce so-called hypothesis, and then we test and see if that hypothesis is correct or incorrect. So I'd like to go to the section 4 of this chapter, because this section deals with population mean, and that's again something that we're probably the most familiar with. So I'm going to take a problem, pick one problem and do it, in section 7.4. So this way you will start to see why and the whole process, how it goes, and what be the result of the calculations, whether we're gonna support some type of claim or not. And in the section 7.4, I guess we all see this old favorite formula for the z-square that we just used in chapter 5, right? Actually in chapter 4. So we'll be utilizing this formula again. So this is the x minus mean divided by standard deviation over square root of n. That's what we will be using here when solve exercises, but there'll be a little extra that I just tried to discuss. So let us take an example so we can better see what is really going on. So how about if I try the problem number 13 that talks about the average weight of M&M candies. So do you get enough chocolate if you purchase it or not? So what do they weigh? So they say that in the package of M&Ms that they say has 1361 candies, there were actually more. And that's way more, right? Instead of 1,300, it's almost 1,500. So the mean weight of the individual candy should be something like that. Okay. So the company wants to produce the M&Ms that do not cheat consumers. So notice that if you put more candies in the package that has the same weight, then you actually, actually they say the weight is 1361. So, and you counted how many candies, so you found how much each candy weighs. So the company wants to produce good calculation result for the weight of each candy. And they claim that mean is not 0.9085. So you said that these candies that you counted have the average 0.9 whatever 85, and they say no, that's not correct, because our candies don't weigh that much, or our candies are heavier probably. So their claim is that mean is not equal to this number. So your calculation is not correct. Well, let's check if the company claims something wrong. And if that's the case, then you could probably sue the company because they sell you lighter candies or heavier candies. So some people I got too much of it, so I got gained weight. So there are various cases. The point is, if you find that their claim is incorrect, well, then definitely they need to change their opinion about the candies, and maybe write something else on their package. So this is really a situation then. So I start by producing hypothesis, and since the claim does not have equal sign, it must be H1, because H0 is always with equal sign, so it'd be the opposite of H1, and the opposite of not equal will be mean is equal to 0.9085. So equal and not equal is what I'm working with in this exercise. So I started the problem and I produced the hypothesis. As usual, H0 and H1, H0 must have equal sign. And we already know that H1 actually stands for not equal, which is either less than or greater than that number 0.9085. So there are two possibilities here. So either less than or greater than that number. So it'd be so-called two-sided picture, just like we have in the last example. So the picture is going to look like this normal distribution. And there'll be a region H1 that I have to split into two pieces. So it'll be H1 here and H1 there. And by the way, if H1 is in those two pieces, then the rest belongs to the opposite, which is called H0. So I need to always see where the border of this region is. And this will be given to me by z-score. And since it's a standard normal distribution with a 0 in the center, then those z-scores will be opposites of each other because picture is symmetric. So everything is broken symmetrically. So this I can say it's a minus z on the left where negatives are, and on the right side will be same but with a plus sign. Here's one more piece of information that's a new one. So they want to always test their claim with a significancy level. And do they give us any level of significancy here, which is called alpha? Looks like they don't give me a significancy level. And if they don't give us a significancy level, then it means that level of significancy is 5%. That's a convention because in the other exercises, they tell the claim with significance level. So they give you either 5% or 10%, so whatever they come up with, or 1%. So those three usual popular values, 5%. So they say if they don't have a level of significance, then automatically it's going to be 5%. So this region, the total of region for H1 will be 5. And that is why each portion of it will be a half, which is 0.025. So the region here is of the area 0.025, and same 0.025, half of significance is the region on the left side. And that will give me ability to get a z-score for this. So I just take the tables and I find 0.025 in it. And for that matter, I need to scroll up. That's where those decimals are. So I can see that 0.025 is going to be, I guess, exactly present in this table in the row minus 1.9. So you can see 0.0250. So it gives me the row minus 0.19 and a column which is 0.6. So the z-score is negative 1.96. And on the other side, it will be positive 1.96. So these z-scores are the opposites on the opposite sides of 0. So please notice that it's all preparation to do the test, because here in the textbook, they gave us some results of the study that I did not use yet. So we just utilize the claim of the company. And besides that claim, we also have that sample of 100 M&Ms was selected. So sample size is 100, that's N. Then you also calculated standard deviation here. And also we calculated the mean there. And mean for the sample, I guess, was, what was the mean here? Let me see. Did they actually give me mean? Because they say 100 weights here. And standard deviation is known as that particular one. And what does they mean for that sample? Did they actually give me? Yeah, here it is. 9147. So for some reason, they decided to write it down below. So here's my standard deviation. Here's my sample mean. So I write it here. It's 0.9147. And standard deviation, sigma, is 0.03691. Okay, so that's what you actually produced when you did your own study checking this out. Now, I need to return back to the tables. There was a question asking me why the 0.025 for the area. So notice this is so-called area. See, that's area. Significance is area. And a z-score is the value here on the column that cuts out this area. So when we have significance level, we are dealing with areas, turns out. So areas are in the middle. So based by the area, we find it. I know it's a little bit new, and that's why definitely has to be clarified. Yes. So anyways, let me go back to this story. And actually, now we pulled everything out. So what I'm going to do is find a z-score, right? Because once I have a z-score, I'll be able to get the corresponding area, and then we'll be able to see what is going on. So I get to subtract from value of x, which is 0.9147. 9147. The mean that the company claims, it's always in the claim, so 0.9085, and we'll test and see if that company could be in trouble because they making the wrong claim. So 0.3691 is our standard deviation that I divide by a square root from 100. So I need to put this in a calculator, and that's why we better use parentheses around the top of the fraction as well as around the bottom of the fraction, remember. So we need to be very careful. So let me go again to the calculator and get this result. I just want to clean this a little bit. So numerator is going to be 0.9147 in the parentheses, subtract 0.9085. See those numbers, they're very, very little, and it is important not to round them. So just keep all the decimals with them. So then we have a standard deviation of 0.03691 is divided by the square root from 100, which is just divided by 10, but I put square root of 100. So there's my z-square. This is a number 1679 ... So that's what I produced in my study. So now the question is, does it belong to H0 or H1? So please notice the number 1.67 and something is a little bit smaller than the 196. So it belongs to H0. That's the region for H0, isn't it? Between negative and positive 196. So since it belongs to H0, I say yes to it because I'm in H0, and I say no to its opposite. So it's always yes to one and no to the other. So what I just did, I denied the claim. You see, you denied the claim. What was the claim? Well, I did statistics. I didn't really care what they claimed, whether it makes sense or doesn't. I just did the calculation and it brought me to the conclusion that we say no to their claim. So what they claimed is that H1, so that mean is not equal. So somebody was testing the company, or actually the actual company was claiming that its candy does not weight what somebody told, and the company was wrong because their claim is incorrect. So it means that company is indeed in trouble. So what they claim is not correct. So they probably better adjust their equipment to make sure that they give the right weight to their candies, because at this stage, they say there's something that's not correct. So here's the, I think, big idea of what's happening and how we can actually do various tests. And I think that's quite impressive. So I know some people like to probably do project, and I would say this is a very interesting idea for project in statistics. Maybe we'll get used to this hypothesis tests a little bit more. And then if somebody is interested in doing a project, I'm always open towards it. So we can always decide on that. If you are working and or have access to some data or something is in your interest, you can just discuss this with me at the end of class, what you have, what you're working on, and we can always test something, and might be even a good article for the newspaper if you either support something or reject it. So let's say I had some realtor, and she was selling some houses. She had statistics on the prices for the market, and she said that's the claim, and she checked it and it worked, and she produced an article based on that. So that's very useful for the real life situations. Of course, I can't really tell you what data to get. I also had a student, he had access to some secret information, and he did some also, but I guess he couldn't publish it because he'd be in trouble, and I didn't want to know what type of data it is, but I just could definitely direct, and we produced a nice test, and that definitely could be utilized. Let's say instead of the final exam, I can go with a project. In fact, I already mentioned that I think I should give you this final exam earlier. So this way, I'll be, I guess you'll be on the safe side. Some of you, I'm not saying about everyone, but some people be on the safe side of getting grade on the class they deserve, because sometimes these emails either don't reach me for some reason, or some people forget to do the exam, or something else happens. And so I was thinking, so maybe I will give the final a little bit earlier. So this way you will have more time to make sure that I got your exam, because otherwise, well, if I give it at the very, very last moment, who knows? Because it looks like things are happening. So, anyways, we'll discuss that maybe a little later at the end of November when we be done with this. But again, that's, I think, very exciting chapter. And of course, you don't have to do project, you just do some problems like we did for the midterm. But we should definitely start to get used to this setting those claims. So let me try to, yes, of course, the practice exams will repeat the same exact process as for the midterm. So you shouldn't worry. I don't really change the structure in the middle of semester because of nothing, so no. So you will have plenty of practice, of course, and I hope you had plenty of practice for the midterm exam as well. So you will be very clear on what to study, definitely. So anyways, my goal is to get used to this setting and setting of hypothesis, because looks like this is the main, yeah, you're welcome, main case for the chapter. So I'll just take a problem number 5, not going to solve it, but just get the claim here. So someone is claiming that mean is greater than 118. So they can claim anything. So here's the claim. So the question is this going to be H1 or H0? And the answer is it is H1, because H0, its opposite must have equal sign. So if there is no equal sign, automatically their claim is an H1. So once you made such a decision, well, the whole process starts going. So I don't want to go through the process. My goal right now is to make sure that we produce the claim. So let's have you try to put claim in either H1 or H0 for the exercise number 6. So for exercise number 6, it says that the temperature is less than 98.6. Okay, so the average temperature, mean, is 98.6. All right, so if that's what you put here in the claim, so question for a quiz. Is this H1 or H0? So you should answer here in the chat, and please do this without a hurry, because you have every time someone says, oh, sorry, I just put the answer to the everyone in class. So don't do that, don't hurry. If you're not hurrying before you put the answer and click send, Well, just make sure that you send it to me, not to everyone in class. Well, it's not a crime, but if you send the wrong answer to everyone in class, you're actually tricking other students in class. So they might repeat your answer, which may not be correct, and that's why it is confusion. So don't send it to everyone in class. Send it only to my name. That's why I give you plenty of time to do this. So take your time. So let me know if this claim that I wrote here is a H1 or H0. And the key idea is to see if there is equal sign or not equal. That's all you need to check, right? Equal sign H0, no equal H1. So it is. That's our little quiz for today. So I'm going to stop the recording.